Here's another example of how to solve a quadratic equation by graphing. Recall that in order to do this, we need to graph the related function and find where it crosses the x-axis. So if I'm trying to solve the equation x squared plus 6x plus 7 equals 0, I'm going to graph its related function, which is y equals x squared plus 6x plus 7. First thing I want to do is find the x of the vertex. To do that, I'm going to do x equals negative b over 2a, or negative 6 over 2, or negative 3. That's the x-coordinate of my vertex. Now to find the y-coordinate of the vertex, I plug that into the function. So negative 3 squared is 9, minus 18, plus 7 gives me a y value of negative 2. So my vertex is the point negative 3, negative 2. Let's put that into the middle of our table. Negative 3, negative 2, and pick two x values that are smaller, negative 4 and negative 5, and two x values that are larger, negative 2 and negative 1, and plug each one of those in. Plugging in negative 5. I have 25 minus 30 plus 7, which gives me a positive 2. Plugging in negative 4, I have 16 minus 24 plus 7, which gives me a negative 1. Plugging in negative 2, I have 4 minus 12 plus 8, which also gives me a negative 1. And plugging in negative 1, I have 1 minus 6 plus 7, which gives me a positive 2. And let's graph those and see what that looks like. So I have negative 5, 2, negative 4, negative 1, negative 3, negative 2, 2, negative 1, and negative 1, 2. So the graph of my quadratic function looks like that. Now recall that what I'm looking for is where this crosses the x-axis. This is a little different from the previous example because it crosses somewhere in there and somewhere in there, and those are not exact points. So what I need to say is that my x values are between negative 5 and negative 4, and between negative 2 and negative 1. And I don't know exactly what they are. Another way to write this is you can do it like this. So x is somewhere between negative 4 and negative 5 and negative 4, and between negative 2 and negative 1.